Hi, and welcome to this. I would like to sort of say a training video. It's in part an introduction to a new type of sensor for, well, I say NaDCC, but NaDCC, which is sodium dichloroisocyanurate. It's a hard one to say, so I'll say it again. Sodium diisocyanurate. I'm sorry, dichloroisocyanurate. It's so hard I have to say it a third time. So in part, this is a sensor or a discussion about a sensor. I want to say for sodium dichloroisocyanurate, NaDCC, but it's a little bit more than that because NaDCC is really a precursor to hypochlorous acid, which is sometimes kind of referred to as free chlorine. So there's a few names, but it's really around about sanitizing water. So I've probably got a slide that slightly describes this in a minute. So yeah, we have this NaDCC, this sodium dichloroisocyanurate. It doesn't have to be the source of the free chlorine, but if you add, and people do add like tablets or have some sort of slowly dissolving formulation that releases or reacts, has a reaction between the NaDCC and the water, and you get this kind of hypochlorous acid, which people then sometimes refer to as free chlorine. So there's a little bit of a confusion about what free chlorine is, etc. But there's I think in the end that free chlorine is in part made up of hypochlorous acid, which is a powerful biocide. So people add it to water to kind of sanitize it and sort of make it potentially I want to say drinkable, but depending on the biological load in that. Now, what we'll be doing in a minute is Solrun is my colleague. Solrun's online at the moment. We'll be taking a sample and we will be preparing that sample, putting that sample on the sensor, and making some measurements on it. We've got a couple of versions of this technology, one that's calibration free and one that is calibrated. So we have sort of two versions. If people want to be quick and easy, then there's the calibration free version. And then if they want the kind of, there's a critical application where they really need some, accuracy, and possibly when the concentration is lower, then people might want the calibration version, which Solon will be doing. You'll see that it involves sensors. You'll see that it involves moving a sample to the sensor. You'll see that we use QR codes. In fact, I can see here that I'm looking at the one-step NaDCC. You'll see that this is driven by a smartphone. The smartphone has the app on it. The app tells the meter what to do. The meter gets the data back from the app and actually sends it to a system called Julie, where data is processed and sent back to the phone so somebody can get a kind of result on the phone. Now, on my next slide, I kind of have this free chlorine, but before I ask Solron to come on, I just want to kind of do a quick kind of understanding of, in general terms, this technology. So I've got a bit of technology in front of me. Now I've got the Sensi All. This is quite a versatile instrument. So we're talking today about doing free chlorine or hypochlorous acid, where the precursor in particular was NaDCC, sodium dichloroisocyanurate. Now what I'm going to do is I'm just going to do a quick test with a very different analyte, but it just gives you a sense of the kind of workflow that you will see when it kicks into Solrun. As you can see, I can just sort of put this sample on here. I'll run it now, and off it goes. So what I'm doing here is I'm actually doing the analysis of caffeine actually in a coffee powder. It sounds very different, but actually the workflow is kind of is pretty similar. That we have sensors, we put 50 microliters onto that sensor. With Solrun's one, the workflow will be more will be longer. She'll have two 30-second steps. Mine was just one 20-second step. So I'm much more close to the calibration free one. And you can see here that I've given the units for this particular assay are 36 milligrams per gram. I just want to kind of quickly change screens for a second as well, because you'll see Solrun do this as well, which is if I go into here, it says upload complete on my phone. And actually what it means is that in real time, the data actually comes up to the cloud, and I'm just checking that was last night. So I'm just going to do a quick refresh here. And it allows us to look at data and see data. In fact, yeah, we can see the data, etc. So not only do we get the result, but we also get the results put into the cloud at the same time as well, as that really helps with traceability on the device as well. So if you have any questions about this, then I'll also be putting a few contact details up at the end as well. So there I can see my results here. So what I'll do now is I'm going to quickly change my camera back to myself, but I'm going to stop sharing. I'm just going to introduce Solon really quickly. So Solon will be doing you a demo. Now, Solon, you're slightly in a fume hood, so you may have to project a little bit louder than normal, but I'll mute and I'll hide my camera and you go through your process. Thanks so much, Solon.
All right. So here we got the sensitive device, just like the one that Martin had, and we have a sensor. And this is the sensor that we use for the sodium dichloroisocyanurates assay. So the first thing I will do is just insert it, just so that I've done it. And then I will show you the app. So here you can see the app on the phone. So I got my phone right here. And it says that it's the NaDCC sensor assay because I've already scanned the QR codes. I can change my test settings. And today we will be testing a sample of unknown NaDCC concentration. So I will click continue, which will lead me to the instructions for how to test this assay in particular. So I'm instructed to mix 1 part of the unknown sample with 9 parts of buffer A. So that's what I will do. I have an empty vial here. So I will just, for this, I will just remove the foam. So empty vial. And what I will do is I will just pipette 90 microliter of buffer A. So this is a standard, this is based on standard addition. So we have 2 samples of known concentration, buffer A and buffer B. And when we add 1 part of the unknown sample, we can, using a standard addition curve, find out what concentration is in that unknown sample. So that's the science behind it. So here you see I've added 90 microliters. So I will also do the same for the B buffer. So I have a empty vial here labeled B. So I will pipette 90 microliter of the B buffer into the empty vial, just like this. So as I said, buffer A and buffer B have 2 different concentrations of NaDCC in particular. So now I will add 1 part or 10 microliter in my instance of the NaDCC sample. So I will adjust my pipette to 10 microliter, just like that. Then I will mix it. So first I'm actually mixing sample B like this. Now this one's done. And then I will mix add 10 microliter of the unknown sample to sample A. Just like that. So now what we will do is we will go back to the test instruction screen. So I will click this here. So we've done the first step, which is mix 1 part of unknown sample in 9 parts of buffer A. And then it says to apply 50 microliter of this sample onto the sensing area of the sensor. So I'm adjusting my pipette to 50 microliter, just like that. And I'll take my sample A And I'm just mixing it a bit with my pipette, just since I just mixed it, just like this. Normally we could use a vortex just to make sure that we have a really homogeneous solution. So now I am pipetting onto the sensor. It's a bit hard with a close-up view here in the fume hood, so you just have to trust me that I just pipette it on. And then I will click the button, Start Measurements. So right now, the measurement is running, and you can see it on the screen. So it's a really good indication for the app that you can see what is happening in the app, and then afterwards you can pull up the raw data like Martin showed you. So it's about 30 seconds for each measurement. So we will do the same with sample B after. So here it says to mix the B buffer, which we already did, and we should now apply 50 microliter of this sample. But in order for us to do that, we need to wipe off the solution that's already there. So I just have some tech paper. I will just make sure to touch the solution just at the edge of it so that I don't interfere with the electrodes or anything, just at the edge so that it will just soak up. And then I will add 50 microliter of the second sample, so B. So again, just mixing it a bit, and then I will pipette it onto the sensor surface, just like that. And then I will click again, Start Measurements, and it will run the second scan. So it is running something called cyclic voltammetry, which is the same curve that same kind of measurement that Martin was showing, where it varies in potential. So it takes about 30 seconds for the second measurement as well. So it's a fairly quick assay. So what actually takes time with this assay is the pipetting and mixing. So now you see on the screen that you get a results back, ppm, and it also said upload complete, which means that it has been uploaded to Julie. So we'll take a closer look at the raw data. So here is the raw data, and we need to refresh the screen just so that the news data shows. And here you see NaDCC, unknown sample. So we'll click that. And you see the curves, the raw data, and the pre-processed data. You also see what peak in particular is being assessed. And then you can also find those values, the ppm values that you saw on your phone screen, both from the buffer A and buffer B. So the strength of Julie is that you have completely control over your tests. You can see how they're doing, you can compare them, and they're there saved for later viewings. So back to you, Martin.
Perfect. Thanks so much. I'll just do a quick kind of summary at the end here, and just kind of say that you saw a couple of demos. You saw me do a nice and quick, easy one, which I kind of call a sort of calibration-free demo. Now, admittedly, I did it on a different analyte, but it did actually show you the power of the entire platform, the SensiAll platform, because in fact, whereas in the end, Solron was actually testing well, we say sodium NaDCC or sodium dichloroisocyanurate. In reality, we're really detecting the HOCl or the free chlorine. I did caffeine, but it just shows you the kind of power of that particular platform. Solron just went through and did a really nice sort of, demo, preparing those samples. And I think it's fair to say Solron said it, that in fact, the biggest time wasn't actually the analysis, it's the sample prep. And that's actually a truism in analytical. And at the end, as Solron said, it's not only you get the result, but actually you know, we can always troubleshoot quite straightforwardly, let's say, because we always have the receipts or the raw data behind what's actually going on. So I hope that was a kind of, you know, what you saw there was the preparation of the sample and the real-time analysis of the sample, and also a sort of broader perspective on the power of the overall platform. If you do have any questions regarding Sense It All and our ability to kind of measure sodium dichloroisocyanurate, NaDCC, i.e. free chlorine or hypochlorous acid in these kind of samples, then don't hesitate to reach out to us. And with that, I just want to say thank you very much, and we will post this video soon, and hopefully it'll be useful for training. Okay, thanks very much.